On 14, this is a subtraction problem, but we have a bit of work to do before we can actually combine these two different expressions. Anytime you have radicals with values inside, you need to simplify those radical numbers. Since these are square roots, we need to consult our list of perfect square numbers and see what divides into these. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared 25, 6 squared 36, 7 squared 49. I'm going to stop there. So let's work on the first radical. We bring down the 2q, and inside let's rewrite 48. Now I know that 4 goes into it, but that you want to always pick the highest one. So 16, if we divide 48 by 16, we get 3. So that goes into it evenly as well, and it also reduces it completely. So rewrite 48 as 16 times 3, and then you have the q squared. Now let's go to the next radical. So we have minus 27 is divisible by the 9. So we rewrite that as 9 times 3, and then you have your variable q to the 4th. So next step is to split up these products. So it's the square root of 16 times the square root of everything else. Let's do that for the next one. Split those numbers up. The square root of 9 times the square root of everything else. And now let's go ahead and simplify further. So the square root of 16 is 4. We're going to multiply 2q by a 4. 2q times 4 is 8q, and then I have that by the square root. Okay, the square root of 9 is a 3, so I have the coefficient is 3 times the square root of 3q to the 4th. So have we done everything we possibly can do? And the answer is no, because we still have these variables inside. So the square root is a 2. We divide the power by 2 to see how many come out and how many stay inside. So for the first one, 2 goes into 2 one time with none remaining. So I have 8q times another q coming out, and so inside I have just the 3. Over here, if I set this one up, I have the 2, and 2 goes into 4 twice, so I have q squared, none remaining again. So if I go one step further, 8q times another q becomes 8q squared, square root of 3. Then I have minus 3q squared, square root of 3. Now, I can actually subtract these because they are like terms. I have 8q squared, square root of 3, take away 3q squared, square root of 3. And so the total then, if you just subtract 8 minus 3, is 5q squared, square root of 3.